Okay, folks, for the last video of lesson 3, I wanted to make a slightly more interesting graph, and then we're also going to focus on velocity concepts, average and instantaneous. So as you will find out very quickly in this course, graphs can have all sorts of different shapes, including curved, and so we will talk later about what the curved part of this graph means. But I'm going to jump in, and this video has a really important concept that is only covered here that I didn't mention before, and so it has to do with velocity. So I'll get right to it, and I'll just write this here. So velocity is equal to the slope of the graph of position versus time. Because velocity is displacement over time, and the graph is position over time, if you calculate the change in position and divide it by the change in time, that is the same thing as calculating the slope of this graph, and so that's what velocity is on here. All right, so here we go. You're going to need a ruler for this if you are copying this graph, which you should be. The first thing we're going to find is the average velocity from 0 seconds to 7 seconds. So average velocity is displacement divided by time. And there's two ways to go about this. You can look at the displacement just based on like the initial and final value, or what I would prefer you to do is think in terms of slope. This is actually going to be the slope of the line connecting the 2 points. The slope of the line connecting the 2 points is going to represent the average slope of that portion of the graph. So I'm going to draw on the graph. I'm going from 0 to 7 seconds. So that's from the initial position to this position over here. And you can see, right, like the motion of this object is complex over that time. So we're going to just draw a line, and we're going to use the slope formula to figure out that velocity. The slope formula is going to be the final y coordinate minus the initial y coordinate. So that's going to be 2 meters minus negative 4 meters. And then that's the rise, and then the run is going to be final x position minus initial x position, so that's going to be 7 seconds minus 0 seconds. All right, so this time I am going to do this all at once. So negative 2 minus negative 4 is 6, and then divided by 7 minus 0, so that's just divided by 7. And so this average velocity is a positive 0.86 meters per second. Okay. So again, velocity is slope, and so that's how that works. All right, the other concept is one that is more suited for calculus, but it's really important for even this algebra-based course. The velocity at t equals 2 seconds. And so I'm going to find that point. 2 seconds is right here, and so we are trying to find the velocity of that point right there. We want the velocity only at that time and not over some interval of time. And when you start calculus, even in pre-calc, you will talk about the different ways that you could do this that increase in accuracy as you go. We're going to skip to the most accurate. What we're trying to find is, if we're trying to find the velocity at 2 seconds, we are actually trying to find the slope at 2 seconds. Now think of it as the instantaneous slope. We are going to need to draw what is called a tangent line. And then we're going to find the slope of that tangent line. So here's how that works. A tangent line is a line that you would draw by hand, and you can do it on our data collection software with the data that you collect, but we're going to do it by hand. We're going to try and draw a straight line that meets up with that point that has the same slope as the curve does at that point. It's very inaccurate when you do it by hand, but when we do it on a computer, it is much more accurate. So I just want you to see what it looks like. So you're going to take your ruler and you're going to bump it up against the curve as well you can. And then using hopefully a different color pen or pencil, you're going to just draw a line with a ruler that hits the curve at that point and hits the curve as little as possible around that. It's hard to avoid it overlapping unless it's a really strong curve, but that's about it. All right, and so now it's time to like find the slope of this line. And I'm going to do a very rough job, and I'm going to say that I'm going to use this point right here, which is 5 seconds and 4 meters. And then I'm going to use this point right here, which is 1 second and negative 0.5 meters. And so I'm going to use those 2 points to find the slope. And that's going to give me the instantaneous velocity. So velocity is the slope of the tangent line. And so that's going to be the rise over the run. So for me, 4 meters minus negative 0.5 meters. And then 5 seconds minus 1 second. All right, so I'm going to do 4.5 meters divided by 4 seconds. So it's 1.1 meters per second. You'll notice that that is faster than the average velocity between 0 and 7 seconds. But it's like the middle of this curve. And so you can think like, one thing I want you to think about is like this part of the curve is almost the very middle. Why doesn't this average velocity match up with this instantaneous velocity if it's like the middle of that? That's maybe a topic for later in the unit. All right, last one is what is the velocity at 8 seconds? This one's easier than it seems. When we say velocity, we mean instantaneous. So we go to 8 seconds, and we see that at 8 seconds, we're here. And we want the velocity, so what I just told you to do was to draw a tangent line. But this is a straight line. So you can't draw a tangent line on a straight line. You have to draw a tangent line on a curve, because the tangent line that you would draw would just be the line that that point is on. So the velocity at 8 seconds is the same as the velocity at 9 seconds, which is the same as the velocity at like 7.5 seconds. A straight line is a constant slope and a constant velocity. So I'm just going to pick the first and last points of this this segment of the line, and we're going to do the slope formula for this. So instantaneous velocity at a point on a line is the same as the slope of the entire line. So I'll do rise over run. The final position is -2. The initial position was +2. The final time was 10 seconds. The initial time was 7 seconds. So this is -4 divided by 3, so -1.3 meters per second. So again, the instantaneous velocity at a time where the line is straight on the position graph means that the instantaneous velocity is a constant velocity for that entire segment. So if I find the velocity of that segment, I'm good. And that's it. So that's hopefully enough to get you started, and I'll talk to you in class.